Welcome to the fourth video on the free and open source Godot game engine platformer series. In this video, we will continue with the same 2D platformer example that we have been developing in different game engines. We will apply the machine state code that we have developed for the player in the last episode into the enemy, and we will create the health bars for both game characters, using two different methods that can be used when creating health bars for your games. Let's dive into Godot. See that we have made the level somewhat bigger and with more elements to make it somewhat proper of a game. We have just duplicated a couple of times Tom app node and adjusted the Z index to send them to different levels of the background, and we have painted them with different tiles. We also set the camera to be closer to the player to have a better view of its action and somewhat reduce the amount of level that can be seen while playing. Review quickly how we have integrated the machine state into the enemy game character. At the top of the skeleton script, we have created the set of states with the enum, and in this case reduce them, as we don't need for this character to jump. We have also created the current and previous state variables that will hold the states in which the game character is. In the physics process, we are resetting the player in range variable to false, as to make sure that we are constantly checking if the enemy is or not in the range of the enemy, allow it to react correctly in each situation. Then, we have transformed the else statement into an elif and added the condition is on the floor to make sure that only if the enemy is on the floor we will be turning around if there is something in front of him. Let's delete the attack and animate functions as each action will be performed inside the state machine. Replace it with the execute state machine. In the attack function, let's remove from the start the statements where we are checking if the enemy is being hit. Each state is exclusive, so we will not have any more problems of attacking while being hit. Let's delete the animate function as we will need it anymore. In the move function, let's remove the code that changes the direction of the enemy when hitting an object different from the player. Next, let's add the execute and change state functions. States to be executed. First, the idle. If we are not yet playing the idle animation, then let's play it and let's make sure that the enemy will not move by setting the horizontal movement to 0. The walk state. We start by playing the walk animation in the case it is not yet being played. Then, depending on if the enemy is moving left or right, let's set the movement direction to max speed or to minus max speed. Time to adjust the attack, which will be very easy, as we will only call the attack function that we have already adjusted earlier on. Let's now add the hurt state. First, let's play the hurt animation, and then let's use the same knockback function that we have used for the player. If the life is below 0, then let's set the state of a new dead variable to true. We will use it to control the transition to the dead state, where we will then clear everything. Let's now deal with the transitions between states. Let's start with the idle state. From this state, we will be able to change to the hurt state if the enemy has been hit, and to the walk, if the player is not in range. We are considering that the enemy will not be attacking from the idle state. Let's now deal with the changes from the walk state. If the player is in range, we will change to the attack state. And if hit, change to the hurt state. From the attack state, if hit, the enemy will go into the hurt state. If the player is no longer in range, then it will go into the idle state. State, the enemy will go to the idle state to recover, or to the dead state if the life is below 0. And from the dead state, we will not go to any other state for now. Let's go up to the start of the script and let's define the dead variable with an initial value of false. Let's run the game to see if the enemy is behaving correctly. It seems that everything is running correctly and as expected. The health bars for both game characters. We will use different systems to show two different ways to do it. Let's start by creating the health bar for the enemy that will be floating above it. Let's create a new empty scene. From the scene hierarchy on the left pane, let's select the option User Interface. This will create for us automatically a control node where we can add our user interface elements. Click on the Add Node button. And in the search box type Progress Bar. And then from the nodes list, select the Progress Bar. Click the button Create to close the dialog box and create the element in the scene. Zoom into the center of the scene, and you will be able to see that the element is there already selected. Click any of the handles on the right side of the progress bar to enlarge it horizontally. You can see that now it shows also in text 0%. Let's start configuring it for our needs. In the right pane inspector, you can see an option called %. If you click on it, it will unfold to show a checkbox to enable or disable the percentage. Let's disable it by clicking on it. Our enemy has only 50 of life, so let's adjust the max value field to be only 50. Let's also set the progress value to 50 as we are starting the enemy with all its life. If we start playing with the number that we have inserted in value, you can see that the progress bar starts to change the amount of filling it has, which in this case is represented by a black bar. We will customize it in a couple of minutes. Let's save it. We are calling it enemy health. Next, let's go to our enemy skeleton scene, and let's add the health bar. Since we need the health bar to move with the enemy, we need to make sure we are creating it under the kinematic 2D node. So, right-click on the kinematic body 2D node, and, from the dialog box select the option Instance from Child Scene. In the new dialog box, select the enemy health scene that we have just saved, and click on the button Open. We will now see the health bar over our skeleton enemy. Click on it to select it, drag it to be just above the head of the skeleton enemy, and resize it until it fits correctly above the enemy. To see how it looks and it behaves as expected. And the answer is affirmative. But it is only a visual effect because it is not yet linked to the life of the enemy, so if we were to make some damage, it would not change to reflect it. Let's add it next. At the top of the enemy skeleton script, let's copy and paste one of the instructions where we are getting a reference to a node in the scene. Rename it to HealthBar and in the node path, let's modify it to look for the reference of the HealthBar. This reminds us that it would probably be best to use descriptive names and not the default ones. So, let's do it now. Let's rename the control to HealthBar and the progress bar to life. You can do the rename by clicking slowly twice on the node, or by right-clicking on it and select the rename option. Once done, let's go back to the enemy script. In the get node instruction to get correctly the reference to the progress bar. Once done, the only thing that we need to do is to make sure that when the script is loading the first time, we set the value of the health bar to the default enemy life value by calling healthbar.value to enemy life. Then, in the take damage function, after we have reduced the life of the enemy from the damage it received, let's run the same instruction again. Let's run the game to see if it is working. End. Apparently, it is working. When we attack the enemy, we can see that the health bar is slowly depleting. Let's now create the health bar for the player. In this case, we don't want the health bar to be floating above the player. Usually, it is not how life bars are used for the main characters. We want it to be always visible at the top left corner of the screen above all the game elements. Since it is the life bar for the player, we want also it to be slightly more complex. And also because we wanted our tutorial to show two different ways how you could create a health bar. So, let's go back to our main scene. In the hierarchy plane, click on the add sign, and in the search box type canvas. From the list of nodes, select the canvas layer node. This will create a frame that will be above all the elements in the scene and that is associated with the camera field of view, so it will always be at the same place. Let's rename it to UI. With the UI node selected, click again on the Add button and in the search box type Control and create it. This will hold our UI elements. Let's click again on the Add Node button, and this time in the search box type Progress. You will see that two progress elements are listed. We have already used the first one for the enemy. Let's choose the texture progress for the player. To customize this new progress bar, we need to focus on the texture options on the inspector pane. If you click on it, you can see that it will display 3 empty drop-down boxes for 3 different textures that will be associated with the background of the health bar and named under. The progress texture, with the bar that will reflect the value of the life, and the over, with the frame that we could put over the bar, or with an icon that we could be using here. We have prepared a simple graphic split into 3 layers that we will be using. The link download will be on the description. So, let's drag the back sprite into the under. Then, the progress sprite into the progress slot. And finally, the over the graphic to the over slot. To see the results, you will need to zoom out the game view until we can see the health bar on the top left corner. The value is currently set to 0. It is why the life bar is empty, so let's set it to 100, which is the life of the player. And you can see that it is now filled in red. Let's run the game and see how it looks in the game. You can see that the bar is there in the top left corner. We could say that it is too small and maybe too close to the edge of the screen. We will address it later on. For now, let's link it to the real life of the player. We could go with the same method that we have used for the enemy, but since we are dealing with the game UI, we may throughout the game development change its structure, and we would have to remember to update all the references to all the UI elements. This would increase the possibility of introducing some bugs. Let's decouple the way the UI is built with the update process. For this, we will be using the Godot event messaging system, which allows us to send information between nodes in our game. Let's start by adding a script to the progress bar of our player life bar by right-click on the progress bar and selecting from the menu, the option Attach Script. Let's name it Player Health Bar. Yes, we know. We are very dull with our namings. But it is just like our synthetic voice. Dull. Click on the Create to create the script. We don't need to make any changes for now. Let's go back to our player script. And, at the top of the script, let's add a new definition. Signal followed by the name we want to be associated with it for future references when we will be updating the player life UI. In our case, player health change. This is telling Godot that we are going to connect our player function to a function that is now yet defined somewhere else in the code. Next, let's go to the ready function of the player bar to be full with the fresh player life. For this, we need to send the data through the signal that we have created in the previous step. We do it by calling a method named emit_signal that takes as first parameter the signal name that we have defined player health change, and as a second parameter the value that we want to send across the signal, which in our case is the player life. Copy this line of code, and let's add it to the take damage function associated with the player. With just what we have done it is not enough, because the signal is not linked to the element that we want to communicate with. So, let's go to the game view, and in the hierarchy pane select the player node. In the right pane, click on the Node tab, which is next to the inspector. The window will list all the signals available, and you can see that just below the player, we have available the signal that we have just defined. Select it. And then, click on the Connect button. In the new dialog box, look for the texture progress bar that we have created for the player and select it. Click on the button Connect. We are sent to the script editor opened into the script that we have created for the progress bar, with a new function created that is based on the name of the signal that we have created. This will be the function that will be automatically invoked, and we emit some data through the signal functionality. Let's define the parameter that we will be receiving, and that will be the life of the player. And then in the code, let's set the propriety value to the new life. Once we have it, we can set the propriety value of the progress bar to the life level that has been passed as a parameter. Let's try to test it. Which has been very difficult as the player seemed to have its intentions. We were able to grab a couple of hits that allows seeing that the life bar is being depleted when the player is hit. Now, let's polish the way the health bar for the enemy looks like, as we have made it very quickly. Let's open the enemy health bar scene. Let's select the progress bar. At the top of the inspector pane, click on the New button. In the search box, type theme and then select the theme option available and click on the button Create. We can see that a new window is opened below the game view, with different options to configure the way the UI element can be configured, but it is not yet ready to make the changes to the progress bar. First, let's save it by clicking on the button Save As. The button Manage Items, next to the button Save As. This will allow us to import the properties associated with the progress bar's customization. In the new window top menu bar, click on the Import Items tab. Look for the progress bar and select it. Then, click on the checkbox under the Import column to mark it as to be imported. Click on the Import selected. Save again the theme. In the inspector for the progress bar, scroll down until you find the option theme. Click on it to unfold the option. You will see that we have a slot to import the theme file that we have just created. Locate the theme file in the project folder and drag it to the theme slot. Click on it, and the inspector is now showing the options that allow us to configure and colors the progress bar. We have several options under the progress bar to customize the font colors and the font used for the text, which shows the actual value of the progress bar. But the one that interests us is the styles option. You can see that we have two slots, BG for the background and FG for the foreground. Let's start by customizing the background. Click on the slot drop-down and select the option New Style Box Flat. Click on the new style box created and we will be taken to a new configuration interface where we can set colors, borders, and many other options for the progress bar background. Let's quickly make some changes. Let's make some adjustments to the border sizes. Then let's choose a new background color. This is the color that we will see below the life bar value as it will decrease to 0. Let's change also the border colors. We know that it is not a very beautiful palette choice, but we are only playing with the system to show its benefits. Once done, you can click on the progress bar on the hierarchy to go back to the main options. Let's now configure the foreground style by repeating the previous steps for the FG slot. To see the final result, you can play with the value property of the progress bar and see how it looks. Not bad. Let's run the game to see it in action. But we can see that there is a flaw in our system. As we can see, the life bar is depleting in the wrong direction. This is because the enemy is flipped to the left, and there so affects the life bar. We also can see that the player life so close to the border of the screen and so small is quite difficult to see when playing. We need to fix those issues. The player life bar is very easy, so let's start with it. Let's go to the 2D game view. Let's zoom out to see the life bar. Click on it, or select the object in the hierarchy pane. Drag it down slightly, and in the inspector pane, under the option Rect, Increase the scale propriety to 1.5. Run the game, and check the new position and the size of the health bar. If you still need some adjustment, repeat the previous steps. Now, let's fix the other bug, that when the enemy flips, its health bar flips too, starting to show the progress in the wrong direction. The fix is very easy to implement. Let's go to the top of the enemy function, and let's duplicate the health bar referencing instruction. Let's name it Health UI. And let's remove the life progress bar node reference. Next, go to the enemy script physics process function where we are flipping the character. Let's add right after it a new instruction that will flip back the health UI back to its original rotation. This will get the progress bar too, as it is the parent node. When doing this, it is very important to guarantee that when you have created user interface nodes, you have correctly set the pivot points of both nodes to be in the center. Let's run the game. And we can see that now the life bar is staying as it should independently of the character rotation. We may have to double check that the life bar is exactly at the middle because we have seen that it was slightly offset. Let's make a final check. Running fine. In the next episode, we will add some scoring and some visual and sound effects to improve the game mojo. Like this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.